Hi, my name is Max. Welcome to Neatbucks Laboratories, and today we're going to do part 2 of our oil-cooled Bitcoin miner build. In part 1, we converted this 40mm ammo can into a housing for our meme generator, and in part 2, we're going to build the heat exchanger. So our meme generator produces about 5,000 BTUs of heat. We have to remove that somewhere. Otherwise it'll literally boil itself alive. So we have a few options for this. So our first option is if you have access to chilled water, perhaps you have a body of water or you work in some settings, for example university where we have chilled water plumbed in, you can use something like this. This is a liquid to liquid heat exchanger, and water will go one way, oil will go the other way. It has a high surface area, so heat exchange will take place. This will work quite well. Thermodynamic, it's actually better than the air-cooled option. It's very compact and it's effectively noiseless. I think it would be very interesting to build a pool heated by Bitcoin miners. We might come back to that later. Today we're going to use the today we're going to build the air-cooled option. So for this, we're going to use this for our radiator. This is a 28-row oil cooler. This is like the eBay Amazon special. It's maybe not aerospace grade, but it'll work for our purposes. If you notice, it has 2 aluminum and 10 fittings, same as that we used on the rest of our system. How it works is oil will flow in this direction through this pipe across these channels and out the other end, and it has radiator ribs, and this airflow this way because it has high surface area. Heat exchange will take place. We're going to replace our fans with this. This is a centrifugal blower, and I got this off of Craigslist from a scrapper, recycler, for about $40. These come out of furnaces, and they're typically rated for 400 CFM or per ton, or 12,000 BTUs. So this one I think came out of a 36,000 BTU furnace, so this should be about 1,200 CFM of full blast. How this device works is air will go through this opening, the motor will spin the impeller. We'll spin the impeller, force air out into this housing and out this way. Now when you get yours, and when you go shopping for one of these, you want to find the smallest one. And how they are wired, you just want to look at the tag. So this is a 110 1/5 horsepower blower, and it'll have a white wire for neutral, a ground wire obviously, and 3, sometimes 4 live wires. So depending on which one of these gets the power, it will vary the speed. I would recommend starting on the highest setting, and then we can move down and adjust it as need be. These are capacitor start, so make sure you get the cap with it. Sometimes they do get scrapped because the cap is bad. They're about $10. Sometimes you'll see various circuit boards and controls on here. We don't need them. They're part of the furnace controls. We just only care about the functioning motor. Now, to mount the 2 parts together, you're going to have to use a little imagination and possibly some thinking. But what I would recommend is if you buy this first and then take this shopping with you. And if you notice, if you find the smallest one of these, a lot of times this will fit quite nicely right over here. If not, you might have to come up with some bracketry. The vast majority of your airflow will come out of this opening, but some will go in here. So if you mount it this way or this way, it doesn't matter as long as your airflow goes across all the ribs. Now, to attach the 2 sides together, the easiest way is if you use some zip ties, or what I would prefer is some metal wire. We're going to attach it today with the ends pointing this way. If you notice, I have drilled a few holes here to match the mounting holes on the brackets. So to do this, feed our zip ties in. Tie this up. You can also do the same thing with the metal wire. And just tighten it up. And then you can just use a pair of pliers to tighten this together. After you've attached your heat exchanger to the blower, we want to fill in all these gaps. We want all the airflow to go through our radiator, no losses. So take some duct tape. And make sure you don't have any air leaks. If you notice, we have this large opening. It has a very high-speed, sharp metal thing spinning in it. You don't want to get your hands in here or have anything fall in here. That would be very bad. So if you're not ducting this into something else, you want to ensure that nothing gets in here. So you can buy all kinds of mesh at your local hardware store. So get a piece of mesh to cover this opening. You want one that your fingers won't slip through, and then just use some self-tapping screws to attach it to the side. Now that we have the blower heat exchanger assembly complete, we need to connect the two sides together. The pump that we're using does not develop a lot of pressure, so we want to keep these lines as short as possible. Also, this pump has very low head, meaning that it cannot pump very high. So we want to keep the heat exchanger and the can in the same level horizontally. For these lines, we have a few options. The most obvious is that we take some aluminum tubing and flare the ends to match our end connectors. This would work quite well. However, in order to flare the ends, you need some special tools, and they look like this. And we would use this cone here to expand the inlet tube. Unfortunately, these tools are rather expensive, and unless you're doing a lot of hydraulics or possibly plumbing your airplane, you probably won't have them. So instead, we're going to use some hose, and we have some AN to hose barb connectors here. And for the hose, we have a few options. We could use just regular basic PVC clear water hose, and this will work okay. However, it will harden up. You can see we soaked this one in oil. It's also quite susceptible to kinking. If you use this, make sure you don't have any kinks in your line, because that will impede your flow and lower the performance of your system. This kind of braided water hose will work too. It's less susceptible to kinking, but it will also harden up over time. I would recommend for this purpose is this. This is Parker PushLok hose. This is low pressure hydraulic hose. It's as you can see, there's a very tight bend radius. It's won't kink. It won't harden up with use, and it's a high quality product. You can get this at either the Parker store or at any hydraulic shop. The local store charged me $5.07 a foot. It's a little expensive, but we only need a little bit. This one is a high temperature hose. You don't need the high temperature. The regular stuff will work fine. I just have this from another project. So these fittings I got on Amazon are, sometimes they say 1/2 inch, but make sure it's the right size. This is actually a 5/8 fitting. You can see the difference. I'm going to show you how to install this hose using this 1/2 inch brass fitting and this gray hose because it's a little easier to see on camera. So to fit your PushLok hose, you need to push this hose onto the barb until the end of the hose pushes on this plastic ring. In order to do this, take some of your mineral oil, lube up the barb, lube up the end of the line, press it up against some hard surface, and push in as tight as it will go. This connection, if it doesn't leak the first time, should be good for its life. You don't need a hose clamp on this either. If you need to remove this, you will need to cut this off. Where you mount your can in relation to your blower is up to you and will depend on your individual circumstances. Today we're going to mount it like this. So we're going to cut a short section of hose here for the oil pump, and a short section using these two 90-degree fittings for the oil return. If possible, mount your oil return as high as on the higher side. This will help bleed out the system. And again, keep your hoses as short as possible. So we'll mark these out and fit them together. Okay. Now that you've fitted your hoses, we need to tighten all our fittings. On the radiator, be sure to support it on the body, because if you simply tighten it here, you can rip this off. So tighten, and remember these are aluminum fittings, we don't need a lot of torque, so tighten them about 1/4 past hand tight. On the bottom, when you tighten these, don't forget you have to support the body of the filter on the inside. Now that we have our hoses fitted, we're almost ready to fill it with oil. If you recall, in part 1 we took this cord off the pump. We are going to wire up both the blower and the pump together, but I would suggest you at first just wire up the pump to make sure it doesn't leak and pumps without any issues.
Yep.
These grommets should not leak, but if they do, perhaps your hole is a little off, or if they got overhang, you can use some silicone to just basically glue it, shmoo it up. Use the black silicone. It's meant for oil primarily. You can get this at any car parts store. If you have to drain your can, you can take your oil return line, stick it right into a bucket, and turn the pump on, and it will drain the pump. When you put your oil return back on, I think this elbow should kind of point towards the center, although I haven't done any real analysis on this. If anybody's watching this and knows anything about computational fluid dynamics and is fluent in something like Fluent, please let me know. I think this would be an interesting thing to model. So we're going to use the power cord from our pump and wire both the pump and the blower together. So how you want to do this is up to you. You can solder this. We're going to use some wire nuts or some chrome connectors, depending on your preference. So wire the pump and the power cord proper wires together. So here we have the hots wired together, and then pick whichever speed you want on your blower. I would recommend starting with the highest speed on the blower, and then if you find it works well, then try the other ones. to reduce your power consumption and noise. On your blower, you notice there's a capacitor mounted on the side. These are meant to be used in an enclosure, so the leads for the cap are exposed. You want to take some insulating tape and cover this up. If you touch this, it's not going to be very pleasant. This completes the build portion of our project. We are now ready to place this miner into operation. Here we see our completed system in operation. Everything's running as it should. We're hashing away, making our mean money in there. About 70 degrees inside here right now, and our chip temperatures have been averaging about 70. If we put this outside right now, it's pretty cold. It's about 40 degrees outside. You can get it down into the 60s. So, if we pull out our power supply from the oil, you can see all the lights are on, and the machine is running just fine. We do have the oil return. Try to do this without spilling. You can see there's a fair amount of oil being pumped through. If you have less than this, check for kinks. You need a lot of oil to go through your machine. Go. For the mineral oil, I use this white mineral oil. Got this from Amazon, but I think it's rather expensive. This is almost $90 for 5 gallons. And you can try looking around locally. If you buy a drum, it's only about $7 a gallon. And we need about 3.5 to maybe 4 gallons for the system. When you run this, it's very important that you keep your lid closed to ensure that no dust or dirt gets in here, but also this oil will pick up water if it's exposed to the air, and it can mist up a little and get on everything. If you use transformer oil, it will smell quite a bit if you don't keep the lid on. If you're outside of the US and you get transformer oil, make sure it doesn't have PCBs, which are compounds that make it more stable, but they're also extremely biotoxic and will make you sick. So this is the complete single miner setup. As you can see, it works quite well. If you like this and decide to build one, let me know. I'd love to hear from you. Please comment, like, subscribe, and keep on watching and mining crypto.